Okay, only two things left. Kirchhoff's loop rule and Kirchhoff's junction rule. And the good news is we've been using both of them all along. In Kirchhoff's loop rule, Kirchhoff was a physicist that did a lot of work with circuits. And his loop rule, what he says is the voltage around the loop, a closed loop, must equal zero as you go around. So he imagines that the power supply adds in voltage, and then each of the resistors takes out voltage. Okay, so he's saying, all right, I'm going around this loop, so the V total is being added in, and then the first resistor is taking out a voltage V1, the second resistor is taking out a voltage V2, the third resistor is taking out a voltage V3, and when I get back to the power supply, it must be equal to 0. Well, if we rearrange this, you will see it's V total equals V1 plus V2 plus V3, which is what we said the other day when we were doing series and parallel circuits. So Kirchhoff's loop rule, really, we've already talked about. The same holds true with parallel. In parallel, if this is V total, then if you go around one loop, it has to be V total minus V1 equals 0. If you go around the larger loop, then it will be V total minus V2 equals 0. But these two just give us that V total equals V2 and V total equals V1, which we already said in parallel. Remember, in the parallel ones, we have V total equals V1 equals V2. So Kirchhoff's loop rule is not new. It's just a different way of stating it. I've written it there in the bottom of your sheet. It says the voltage around a closed loop must equal 0. One adds in the voltages of the power supply and subtracts the voltages of the resistor. So that's his loop rule. The last one is his junction rule. We've been using this one too. All it says is that the current flowing into a junction, and in this picture here it would be I total flowing in, must be equal to the total current flowing out of the junction. If this is R1, then this would be I1, and if this is R2, then flowing out here would be I2. So all Kirchhoff's loop rule says is then I total must be equal to I1 plus I2, which we already said the other day. But it works in any junction. You don't even have to be able to see the rest of the circuit. Like I could tell you there's 8 amps flowing up from the bottom here, and maybe there's 3 amps flowing in from this side. And then if I said to you, okay, there's 5 amps coming out, what must be in this branch? So going in, we have 11 amps. So far coming out, we only have 5 amps. And so in this branch, there must be 6 amps coming out. So the total current flowing in must be equal to the total current coming out. Let's just do one more. What if I had 3 amps flowing in here? And I had, let's say, 2 amps flowing in here. And I had 7 amps coming out on this one. What must be in this 4th branch? Well, going in we have 5 amps, coming out we have 7, and so total going in must be equal to the total going out. That means in this 4th branch this time, there must be 2 amps going in. So in 3 of the branches we have current going in this time, and we have current coming out in just 1. But total going in is 7, total coming out is 7. Okay, and that's it. Those are Kirchhoff's rules. The only thing now we have left are the complex circuits. We will start those on Monday after we address any issues. Have a great weekend.